Hello everyone, we will now start unit number 3, magnetic materials. Magnetic materials plays very important role in modern technology. Magnetic memories, compact disc or tapes, televisions, motors, generators, transformers, telephones are some of the example of applications of magnetic materials. In this chapter, we will first define magnetic parameters like permeability, magnetization, magnetic susceptibility, etc. Then we classify the magnetic materials depending on alignment of magnetic dipole moments within the materials. The magnetic materials are categorized into five groups, namely first diamagnetic, second paramagnetic, third ferromagnetic, fourth antiferromagnetic, and fifth number is ferrimagnetic. The materials which exhibit the phenomena of paramagnetism, diamagnetism, anti-ferrimagnetism are considered to be non-magnetic, while ferromagnetic and ferrimagnetic possesses very strong magnetic properties. A large number of devices use mainly these two magnetic phenomena. Then we will see other classifications of magnetic materials as soft and hard magnetic materials. Soft magnetic materials can be magnetized and demagnetized easily and hence can be used in AC applications, while hard magnetic material retain magnetism permanently, so used for making permanent magnets. The magnetic parameters materials is permeability, magnetic dipole moment, magnetization, magnetic susceptibility, Curie temperature. This is the five parameters of magnetic materials. So basic, what is the Coulomb's law or law of magnetism? The already learned in the 12th standard or engineering first year, the Coulomb's first law or Coulomb's second law. What is the Coulomb's first law? Coulomb's first law, like magnetic poles repel and unlike poles attract each other, is called as the magnetic magnetism law or Coulomb's law. What is the second Coulomb's law? The force is directly proportional to the product of the pole strength and inversely proportional to square of the distance between them and nature of the medium surrounding the poles. Suppose the force F is directly proportional to pole strength of the pole is the m1 m2 is the pole strength of the pole, and d square, d is the distance. Okay, the second law of Coulomb's law. The magnetic field, what is the magnetic field? Suppose this is a permanent bar magnet, is the north pole and is the south pole. Okay, and is the iron pieces. Okay, the region around a magnet in which it exerts forces on other magnets and on object made of iron is magnetic field. The magnetic field is the cause moving charges the produce magnetic field. Suppose it's a line of motion. Okay, the charge Q and is the force F, and uh, magnetic field density is B bar. Okay, suppose this is the cutoff U is into page, this is the charge Q and this is the field density. Okay, suppose important definitions related to the magnetism. The magnetism is a magnetic field. What is meant by actual magnetic field? Magnetic field, the region near to the magnet where forces act on magnetic poles is called as magnetic field. Okay, magnetic lines of force. What is my magnetic lines of force? The magnetic field around a magnet is represented by im imaginary lines is called as magnetic lines of force. These are imaginary lines. Okay, is known as or magnetic lines of force. Okay, the lines of force means what? Exact. This is the lines of force means what? The isolated n pole. Suppose this is the n pole, and it is allowed to move freely in magnetic field. Then the path along which moves is called as lines of force. The directions always for line of force, the north pole to south pole, as shown in the figure. Okay, the properties of magnetic lines of force. The first property, the lines of force are always originating on n pole and terminating on south pole external to magnet. These are always start from north pole and end from south pole, always external part. Okay, first property. Second property, each lines from closed loop. See here, this is the north pole and south pole. This is the closed loop, always this is the closed loop. Third property, line of force never intersect each other. Line of force never don't intersect each other. Then fourth number, line of force which are parallel and traveling in the same direction. The parallel same direction, so is the same direction. Okay, fifth number, magnetic lines of force always prefer a path offering least opposition. Okay, this is the properties of magnetic lines of force. Then next, the magnetic flux. What is meant by magnetic flux? The total number of magnetic lines of force produced by a magnetic source is called magnetic flux. The magnetic flux 1 Weber. 1 Weber is equal to how many lines of force? It's 10 raised to power 8 line of force. Magnetic flux density is denoted by B, and the unit is meter square, Weber per meter square. What is the magnetic flux density? The flux per unit area. The flux per unit area in a plane at a right angle to the flux is called as magnetic flux density. The plane at a right angle to a line of force. The B is equal to 5 divided by A. This is the figure. Magnetic lines of force. Magnetic lines goes always north pole to south pole for external, and internal south to north pole, and is the cross sectional area. Okay, the magnetic field strength. What is mean by magnetic field strength? Or is a magnetic flux density, magnetic field strength, or magnetic field density intensity. Magnetic field intensity is a magnetomotive force, is mmf per unit length is called as the magnetic field intensity. Magnetic field strength or magnetic field intensity is denoted by H. H is equals to mmf. mmf divided by length. mmf means number of turns into flow of the current divided by length of the conductor. The SI unit is ampere turns per meter. Magnetomotive force. What is meant by magnetomotive force? Magnetomotive force, the product of number of turns in the winding and the current flowing in it is a measure how much excitation is applied. This product is called as magnetomotive force. mmf is equals to number of turns n into I. The SI unit is ampere turns. Thank you, students.